first question, the pH of 0.1 molar solution of the following salts increases in order. So there are 4 salts or 4 compounds given: NaCl, HCl, NH4Cl and NaCl. So first of all, we know among them HCl is a strong acid and its 1 molar solution H plus concentration is 0.1 molar, and hence pH for HCl is equals to 1. NH4Cl hydrolyzes in solution and gives acidic solution which is less acidic than 1 molar HCl. So next, NaCl, which is not hydrolyzed in aqueous solution and its pH is equals to 7. And last, NaCN undergoes hydrolysis in solution to give alkaline solution. So pH increases in an order: HCl, then NH4Cl, then NaCl, and then NaCN. So the correct answer among the given option is option B, that is HCl, NH4Cl, NaCl and NaCN. Option B. Looking towards the next question, the degree of hydrolysis in hydrolytic equilibrium, A minus, that is the anion, plus water gives you Ha, that is an acid, plus OH minus, hydroxyl ion. At salt concentrations of 0.001 molar is, so Ka given is 1 into 10 raised to minus 5. So we know that degree of hydrolysis, that is Kh, is equals to Kw, that is ionic constant, upon Ka. We know that Kw is equals to 10 raised to minus 14, which is fixed, and Ka given in the question is 1 into 10 raised to minus 5. So from here we get that Kh is equals to 10 raised to minus 9. We also know that Kh is equals to alpha square C. So therefore alpha is equals to under root of Kh upon C. Kh we find out here that it's 10 raised to minus 9, and concentration of the salt given is 0.001 molar. When we solve this out, it gives you 1 into 10 raised to minus 3. So correct answer for this question is option A, that is 1 into 10 raised to minus 3. Looking towards the next question, the solubility product constant, that is Ksp, of MgOH twice is 9 into 10 raised to minus 12. If a solution is 0.010 molar with respect to Mg plus 2 ion, what is the maximum hydroxide ion concentration which could be present without causing the precipitation of MgOH twice? So we know that MgOH twice dissociates as Mg plus 2 and 2OH minus ion. So the Ksp is equals to S and 2S the whole square. So Ksp can be written as S into 4S square. Therefore Ksp upon S into 4 is equals to S square, which can be substituted. Ksp value is 9 into 10 raised to minus 12 the whole upon S, that is solubility given 0.010 molar into 4. It gives you S square, that is 2.25 into 10 raised to minus 10. And for S, we have to take the square root of this, that is 2.25 into 10 raised to minus 10 square root, and it comes out to be 1.5 into 10 raised to minus 5 mole per liter. So correct answer for this question is option mole per liter, that is molar. So correct answer is option D, that is 3 into 10 raised to minus 5. It's C, 1.5 into 10 raised to minus 5 mole per liter. Option C. Looking towards the next question. 100 ml of 0.04 normal HCl aqueous solution is mixed with 100 ml of 0.02 normal NaOH solution. The pH of resulting solution is, so we know that N1V1 is equals to 0.4, 0.04, which is given in the question normality, into volume, that is 100 ml. It is equals to 4, and N2V2, which is equals to 0.02 normal into 100 ml, which is equals to 2. So N1V1 minus N2V2, which is equals to N3V3. That is 4 minus 2 equals to N3 into 200. So therefore N3 is equals to 10 raised to minus 2 molar. Now pH is equals to log to the base 10 of 1 upon concentration of hydroxyl ions. So that is equals to log to the base 10 of 1 upon 10 raised to minus 2, which is equal to 2. So correct answer for this question is option C, that is 2. Now looking towards the last question, by adding 20 ml of 0.1 normal HCl to 20 ml 0.1 normal KOH, the pH of the obtained solution will be. Neutralization reaction will take place and form salt of strong acid and strong base, which does not neutralize, and thus pH is equals to 7. So the correct answer for this question is option B, 7.